Hello everyone, I welcome you all back to today's lesson. So this is the question that I gave you. It is not really exactly like the way it came, but this one is just the same as that one. And a lot of people faced challenges in answering this. So I want to make it very simple so that we try to understand everything that we are going to discuss here. So I'm going to show you how we get to answer this. Then I'll give you an exam question exactly like this. So this is just a continuation from where we ended last time. I gave you this exercise that was something like this, just numbers are different. I just want you to get this. After you get an understanding on this, that's when you can answer that one. So the first question was telling us to find the acceleration in the first, like in this question, you are told to find acceleration in the first 10 seconds. So how can you find the acceleration in the first 10 seconds? So this is time here in second. So you know that acceleration, so for those of you that are writing questions, saying find the acceleration, find acceleration in the first 10 seconds. Find acceleration in the first 10 seconds. So how can you find the acceleration? It was accelerating. Obviously, it started from where? Started from rest. So from this rest position, increased its velocity until it reaches that point. Then we know that acceleration is equal to final velocity minus initial over time. This is the formula that we get to use, and this is the formula that you need to understand. So those of you that recently started, you need to make sure that you've got a personal book that you are using. You've bought yourself a new book where you'll be writing everything that will be discussing with you. Don't today you write on a paper, tomorrow you write on a different paper like that. You get confused. So you say acceleration is equal to, it started from where? You say final velocity. So it started from rest position. It started from 0. So this is your initial velocity. Then it ended at what? It ended at, have you seen the time there? At 40 meters per second. So this is the initial where it started from. This is the final velocity where it ended. So the formula is what? Final. The final, we get it there like that. The final is what? 40. The final is 40. So you say 40 minus, started from initial 0, over what is the time? The time is what? The time is 10. So if you do calculations here, what are you going to have? You're going to have, this is equal to 40 over what? Over 4, over 10, which is equal to 4 meters per second squared. This is the answer. In my first lesson, I told you that you need to make sure that acceleration is having a square there, meters per second squared. You are not supposed to forget the squared there. So make sure you indicate the squared there. You are not supposed to forget about the square. Once you forget this square, then automatically everything becomes wrong. So I want you to get this. I want you to understand each and everything that I'm doing here. So we've answered the first question where we were told to find acceleration in the first 10 seconds. This is how you get to do it. Then let's move to the next question. The next question is telling us to find the distance covered. So you are told the next question is where you are told to find the distance. Find the distance covered. So this distance covered is for the O journey. Distance covered for O journey. For the O journey here, so you calculate the distance covered for this O journey which is there. This is the journey which we are given. This is the what? That is the journey which we are given. So how can you answer a question like this? So you know that this thing was starting from here. It moved like this. It went there. It ended there. So here where it ended, have you seen the shape it is making? What do we call this shape? What do we call this shape? This is a trapezium. This is a what? This is a trapezium. So what's the formula for a trapezium? You say distance is equal to half A plus B H. This is a formula for a trapezium. So you need to make sure that you know this formula. So once we calculate this one, this is the distance which is here. This is a trapezium. So we say distance is equal to half. What is our A? So A and B, according to what I told you. I told you that these are two parallel lines. Like this one that is like this, and this one that is in that manner. So these are the what? These are the two parallel lines that you have to know. So like this, you say, okay, what is A? This is the long one. This is longer than that one. So this is B. The short one is A. Then this one here, this is our height. So H, that one. So our A, have you seen this is cut in there? So our A is from there to there. Difference there is 10. 20 minus 10 is 10. So A is 10. Plus B is from this point to that point. 0 to 20. So it is 20. Height. What is our height? From here to there. Which is what? Which is 40. So then when you calculate that, you say distance is now equal to half. Half of what? 30. Then multiply by 40 like that. This is what? 15. 15 times 40. What is the answer? What answer are you getting? So this is physics. We are allowed to use calculators. You can use a calculator there. It is what? 600. So you say 600 meters. This is the distance covered. Just like this, you are done. So this distance covered for the ocean, for this to move from here to there, which means it covered a distance of what? It covered a distance of 600 meters. So the distance was 600 meters. For some of you that are seeing that you want to use another formula where you cut, this is a what? This is a triangle. Then this thing which is here is a rectangle. You can answer it in that manner. You still get the same answer. But it is better you just solve it together so that you see how it is coming up. You just calculate everything at once. Not where you calculate this one here, you calculate that one there. It's just good you calculate everything at once. So this is what you have to do. Then the next question which usually come is where you are told now to find the average speed. Question is telling us calculate the average what? Average speed. How can you find the average speed? You know that average speed, according to the formula that I gave you, so there is nothing new here. We discussed all these things. It is just revision that we are doing so that we try to catch up with what we are supposed to look at. So I'm going to give you an exam question that you are going to practice. I see how we are coming up with this. So here we are doing questions where a graph is already plotted for you. If we understand this, we will now look at a question where you are not told, where a graph is not given. It's you to plot that graph. So let's start with this one where a graph has been plotted for us. Then we just calculate one or two things. So what is the total distance? So you answer this according to the question. Instructions are very important. The distance is what? 600 meters over. Time taken 20. The time taken is what? 20. So you put your 20 there. You say 600 divided by 20. What is the answer? The answer is 30. So 30 meters per second. These are the units. In physics, units are very important. Once you forget a unit, then everything automatically becomes wrong. So let's make sure that we understand this. We get all the necessary concepts that we need to know on this topic. This is a very simple topic, and I believe we can all get an understanding from this. So let's make sure that we get this. We know how to go about this. You get all the necessary things that you are supposed to know on this topic. Units very important. Even here, if you put other units, the answer can be correct, but they will still mark you wrong because of wrong units. So let's make sure we get that. We try to understand that one. So away from this, let us look at force. Let us look at force. We look at force. Let us look at force a bit away from this, but the exercise will cover this. So you write this in your book. Everything I'm writing, you need to be writing. So force. What is force? What is force? What is force? How can you define force? Force is a pull or push. So it's a push or pull on an object. On an object. This is how we get to define force. And force is measured in newtons. So SI unit is what? Is newtons. This is the SI unit. It is what? Newtons, like this. What formula do we use? The formula is force is equal to mass times acceleration. This acceleration which is here can be due to gravity. So have you seen the formula which I've written here? This is the formula that you need to know. Force is equal to mass times acceleration. So you say where M is the mass. Mass is in what? Don't forget, kgs. Then A. A is a what? Acceleration. So now, what I mean is that if we, on the same graph that you are plotting, you are told to find the acceleration, you are told to find the force due to its acceleration. You say force is equal to, you get the mass, you multiply it with the acceleration, which you found at first. So you're not supposed to put 10. You put the acceleration which you found. If we talk about the example that we did, if the mass is given as 40, you say the mass is given as 10.2. This is the mass. Times the acceleration that we found was what? Was 4. So then 10.2 times 4. What's the answer? 10.2 times 4. What answer are you getting? 40.8. You're getting 40.8. You just say newtons like this. So I've just assumed that the mass which is here, let's say that car that was moving, that was its mass. So I've just assumed that it was the mass because these are the questions that you are going to find, and these are the questions that you'll be practicing. So let's make sure that we know this. Let's make sure that we understand each and every question that may try to come in those lines. So let's make sure that we get this, we understand all the concepts which are needed. Let's make sure that we understand. So make sure you are writing these things down. Let's make sure that you are able to answer questions like this. So let me give an example on this. Let's take one example. So let's say example. A car of mass 1000 kg. A car of mass 1000 kg was moving as shown below. This is the question. Then the car which was moving is here like this. This is how it is. It is something like this. This is how it is. So the car was moving like this. Let's say it was moving like this. Went there like this. Here you are given 10, 25, 35, 0. This is time, which is in seconds. Here we've got the velocity. Let's say there we've got 20. So that's the velocity this side. That's the velocity which you are given this other side. Velocity which is in meter per second like this. The first question, question 1, you are told to calculate acceleration in the first 10 seconds. How can you calculate the acceleration in the first 10 seconds? So what you are going to do is this. You know that acceleration is equal to final velocity minus initial over time, which is equal to, what is your final velocity? It ended where? It started from here, then ended there like that. So it is what? 20 minus 0 over 10. The time difference here. Have you seen? So it is 10. 20 minus 0, it's 20. Divided by 10, it's 2. So 2 meters per second squared. So that is what? That is the acceleration in the first 10 seconds. The other question that you have is this one. So we've calculated the acceleration. Hope you've... let's make sure we copy everything. So the other question, question 2, calculate the force due to its acceleration. This is the question. So you know the force is equal to mass times acceleration. So force is equal to, what is your mass? You check the mass is what? What's the mass? You were given that mass, 1000 kg. So it is the same one you're going to use here, 1000 times the acceleration we found it was what? 2. So 1000 times 2, it is what? 2000. You say 2000 newtons. So meaning this is what? This is your force that you have calculated. This is how you need to calculate the force. So these are the procedures that you need to do These are the steps that you need to understand. So now let us look at maybe the question is like this. You are told to calculate question 3. Question 3. They're telling you calculate the acceleration. Calculate the acceleration in the last 10 seconds. So you want to calculate the acceleration in the last 10 seconds. So how can you calculate that one? You know that in the last 10 seconds, it is here. 35 minus 25, here we've got 10. So the acceleration that they are talking about is this one, from here to there. So what type of acceleration is in this format? This is called what? Deceleration. This is deceleration. So it is called deceleration. It is the negative of what? Acceleration. So whenever you are talking about the deceleration, deceleration is what? Is negative. So this one which is here, this is the acceleration positive. But this is the deceleration. So the answer here, which we are told to calculate the acceleration in the last 10 seconds. So it started from here. That's where it started from. So started from there. So this is your initial U. It went until it reaches there, which is your final velocity, V. So you use the same formula, but it is the answer that is going to tell you that this is the negative acceleration. So you say acceleration is equals to final velocity minus initial over time, which is equal to, what is your final velocity here? It is what? It is a 0 that is there. There is a what? A 0. So you say 0 minus initial. Where did it start from? There. Started there. What reading is there? 20. So 0 minus what? 0 minus 20 over time. You are already told in the last 10 seconds. So 10, which is equal to negative 20 over 10. What is the answer there? The answer is negative 2 meter per second squared. This is your answer. Have you seen the way I've calculated? So this is the negative acceleration. The answer is negative. This is to tell you that it was decelerating. So whenever it is decelerating, that is how it gets to move. So that's how you need to answer that one. These are the procedures that you need to put into consideration. So let's make sure that we know how to answer this. Let's make sure that you understand, you know how to practice all these questions which are here. These are simple questions. So I'm going to give you an exam question that you are going to practice. After I see how we are coming up with the exam question, then tomorrow we are going to get a question now where you are not given a graph. You make your own graph, then you answer the questions that are given down. So this is what we are going to do, and this is where we are going to end from. Let's answer the exercise. Let's see if we are able to understand what we've learned. Let's put into practice what we've discussed here. So let me give you a question. I see if we are going to answer it, if we manage answering that question. So make sure you keep time. You keep time. Make sure you observe time. Thank you so much.